Okay, now you're going to need the booklet Solving Problems Involving More Than One Right Triangle. So I'm going to go through the 3 examples in there and one video or one video for each. There we go. And then you can finish through the booklet and then we are actually done the course. So let's start with example 1. We're solving a problem with 2 triangles. We want to find the length of BC to the nearest tenth of a centimeter. Well, I've got this 49 degrees, but I don't have any sides for this triangle. And we've only learned how to solve right triangles. We've got this big triangle, but we don't know how to deal with that because we haven't done that. There is a way you can do that, but we're not there yet. But we do have these 2 right triangles that share a side. So we can actually calculate the length of BD and then use that to calculate the length of BC. So let's start with that. So we're going to look for the length of BD. So here we have an angle 26 degrees, and in this case here we've got the hypotenuse of this triangle here, ABD, and this would be the adjacent, so this side right now is the opposite. Okay, so I've got the opposite and hypotenuse. If we think SOHCAHTOA, opposite hypotenuse, we're looking at sine. So sine theta equals the opposite over hypotenuse. You'll notice that I write this down pretty much every time. The reason is twofold. One, it helps me remember the formula. And secondly, it makes sure that I'm putting things in exactly where they need to be. So sine, I know theta, it's 26 degrees. I don't know the opposite, so I can call that x. I could just call it BD, whatever I want. BD over the hypotenuse, which is 22.9. Now, I've got that on the top. Again, if you want to look at the little triangle, it would tell you multiply the hypotenuse times the sine of the angle. And I'm going to say BD is equal to 22.9 times, I don't need to write the times in, just write sine, it's 26. Sine of 26 degrees. Okay, so I can put that into my calculator, pull up the TI here, and I say 22.9 times the sine of 26 degrees equals, and we've got 10.0386. Now you could keep this in, keep more decimals. I'm just going to go to the nearest tenth of a centimeter here too, and the nearest tenth would be 0 because that 3 would get it to round down. So BD is equal to 10.0 centimeters. Well, now that I know that, so this is 10.0, I can solve for BC. So I've got, again, here's the hypotenuse. I'm looking for the hypotenuse. I have the opposite, so I'm now still using sine. So now to solve for BC, I'm still using sine. My formula is sine theta equals opposite over hypotenuse. Well, here my theta, my angle, is 49 degrees. My opposite is 10.0, and my hypotenuse, I don't know. Or I could just, again, call that BC if I wanted. Let's do that. So BC. Now remember, if we had the BC on the bottom, or whatever we're solving from the bottom, we just flip these 2 around. So BC is going to equal to 10.0 divided by, divided by the sine of 49 degrees. Now put that into the calculator. Again, you can use the triangle. You would cover up, we're looking for the hypotenuse, cover up the hypotenuse, and you would see it's the opposite over the sine of 49. So on our TI, I'm going to say 10 divided by sine of 49 degrees is equal to, and here's my answer, 13.25. I'm rounding to the nearest tenth, so that'll be 13.3. That'll round up. So BC is equal to 13.3. Make sure you have your units, centimeters,